In this video we will do a quick teardown and maybe a fix of cheap Chinese made power adapter. It was used by a friend of mine for charging his batteries and it has failed, so now I will try to fix it. I have no idea what happened. He told me that he put it in the socket, some sparks came out of it. He doesn't really know where they come out from, and the LED went down slowly. So I don't think it's a short on the output. It might be something wrong with the input. I have no idea if I can fix this. I have not too much electronics knowledge, just basic, so don't do exactly what I do, but we will try to find out if my knowledge is enough to fix this and see what's inside of it, even if we can't fix it, or at least I can't fix it. And keeping in mind that is very cheap Chinese made, really, maybe you can hear it. It bounces around, so it has almost no weight to it. If something is very wrong with it, probably it's too expensive to fix, and we will not fix it. Of course, it has two clips at this end. I've got no idea what kind of clips. There always are clips and I hate them. Because actually until you take it apart, you can't know in what direction they should be bent to release it. One moment, I take a closer look at it. Of course, they should be bent inwards this time. It's not a rule, but this time inwards. I'm really curious what could have failed in this to make so much sparks. Okay, so absolutely nothing holding this board in place except for this USB, which is not enough from what I think. The caps aren't blown. Transformer looks okay, not blown, not darkened. Resistors okay, not blown. Of course, it does not have a fuse. This might require some more measurements, because everything seems to be okay at first sight, and I can't really see why it would make sparks. I think that this is the primary side of it, a little gap, secondary side, with, if I'm not mistaken, an optocoupler. HFL caps. I have no idea, but I don't think they are very good ones. At least they are 105 degrees rated. So I will take out my multimeter, do some measurements, and then come back to you. Okay, now I see something. One moment, so you might see it. I pull this diode away, and I'm not really sure. My camera is not focused, and maybe the whole time it wasn't focused where it should be. Sorry for that. I'll try to focus it again. Okay, this I think is better. This resistor has the paint from its lower side blown away. You might see that, although I'm not really sure. So I will have to measure it, and this might be our problem. Why would that resistor blow like that? I'm not really sure. Maybe it was just too close. Let me see. Okay, the diode is on one wire, and this resistor is on the other wire. Okay, incredible. Chinese crap all over again. So if we put it back like I found it, the only thing separating one phase from the other one was less than a millimeter gap and the paint on the resistor. So I'm almost sure that the problem was that it was an arc between this diode and the resistor, maybe blowing the resistor. I will check it in a moment with a multimeter and we will see. I will get back to you. So we're back. We'll test the resistor, of course, with a cheap Chinese multimeter. What better way to fix some cheap Chinese things? Is just in simple continuity mode. I will not unsolder it this time, but when checking components, it's always better to unsolder them. In this case, maybe I'm a little bit too lazy for the moment, and it should be in series, so I don't think we have any problems. Like, where? Okay, you see now I'm making contact, beeping. Through the resistor, nothing on the display also. Okay, it's clear this resistor is completely broken. I hope you can see what I'm doing. I will also test this diode because it's just close to the problem and I want to see if it's damaged or not. Okay, we don't have enough continuity to make this beep, but I'm getting a reading about 1 kilo. Let's see other way around. It should be 0 if it's good. Yes, actually not 0, it should not display anything, and it's not displaying, so the diode is alive. It did not release the magic smoke. All the magic smoke released was from the resistor, which value Sadly, I don't know from the top of my head, from the lines, I don't know resistor color code from my mind. I have to search for it online, but I'm pretty sure I will have a replacement resistor, and I will tell my friend to be very careful when using this, because it's pretty low quality. But at least from what I can see here, it has a pretty decent gap between the primary and the secondary, so at least it will not electrocute him in the worst possible scenario. But because it does not have a safety fuse, from what I can see, that's a little bit dangerous and it could catch fire. Lucky thing that these wires are so thin that they might actually blow up first before everything catches fire. Anyway, I will tell him to be very careful, and you all should be very careful when using non-branded, at least Chinese made things. Safety for them is absolutely not important. They make them as cheap as they can and they sell them worldwide. So I will search online for the value, search a resistor on my spare parts TV boards, and hope I can find one to match, solder it, test it, and that's about it. So maybe this time we actually fix it. Okay, I'm back. After some online searching, I found out that brown, black, gold is 1 ohm resistor with plus or minus 5% precision. So I search on my boards for exactly the same type of resistor, brown, black, gold. So this is no-brainer that they are exactly the same, and I will replace it. And I realized something else. Sorry. I used my multimeter in continuity test mode to check this resistor. It did not beep, okay? So the resistor must be bad. We check the good one, it beeps. But there is a problem. I'm not sure if this is how all multimeters work in continuity mode, but at least this one seems to check only for very low resistance. So if I check another resistor that I know it's good, because I moved it earlier and it has, I'm not really sure, a few kilo ohms. It's a good resistor, but my multimeter will not beep. So if this resistor, the bad one, would have been a higher value resistor, my multimeter would not have beeped. I would have thought that is bad, and maybe it was good. In this case, I was lucky and it worked, because it's a low value resistor, and continuity mode works for low value resistors, at least on my multimeter. So I will solder the new resistor here, and then we will give this a quick test. Also, I have discovered some other flow with this. As you can see, we have this wire 230 volts right next to what should be, from this point onwards, low voltage part of this. So actually when this is closed, we have only about, I'm not sure if you can see, something like 2 millimeters, 3 millimeters. If you see the other wire, it has the protection taken off for a big distance. If that would have been glued here and would have been bent like this, you could get 230 volts in an USB port, and that would be very bad. So before I will close this, I will put some electrical tape over this, so it will not be able to touch anything dangerous. But this is again very cheap and bad design, from at least from what I can tell. I don't like it at all, but it should work if my colleague slash friend will be very careful with it. So we will continue a little bit later. I'm back. I've soldered the new resistor in place, bend it as much as I could away from this diode, bend this as it was when I first opened it, because it has this plastic, for lack of a better word, thing through which the screw goes, and it will hit it if I don't bend it. Again, bad design, but what can you do? Looking at this resistor, I realized another thing that I hate. I will try to focus the camera. Okay. These color coded resistors, in different lighting, it's very hard to tell the colors. This, some people might even say it looks a little bit like dark red. But luckily for me, in this case, brown, black, gold means 1 ohm. Red, black, gold would mean 2 ohms, and I don't think it would be enough to be dangerous in this case, to heat up the resistor too much. But I'm pretty sure that this is brown, so I'm replacing exactly with the same value resistor. But I don't like this type of resistors, and I like them even less when they are blown like this one, so I cannot double check them with a multimeter to see if the calculation based on the colors is right. I don't even have a clue how, you see how it's blown here. I don't even have a clue how colorblind people or partially colorblind people use these resistors. I might ask a friend that I know it's partially colorblind, how he can work with this, because he works in electronics. Probably he asks people around him. I'm not sure how he does it, but anyway, what can you do? So now I will have to tape this so it will not be dangerous, close it, and of course test it, and then give it to my friend. So be right back. Okay, I've gotten my tape ready. I will put it like so. This comes a little bit over. So now this phase is not too close to the secondary of this power adapter. Just to be on the safe side, of course, even more tape. doesn't really want to stay in place. Okay, not perfect, but a lot better than before. Okay, everything seems to be in order. So let's put it back together. Oh, of course. Why not? The LED is moving. Great. So, again, a quick fix. Let me see this time if I can do it on video. I will see if the cable is long enough. I did not prepare for this, of course. Okay. Yes, I'm using a soldering iron because it heats up a little bit faster. Okay. With that finished, it's time to put it together. You can see this is meant to be on the outside, these edges, but then the board doesn't reach where it should stay because it has a channel there, but the channel works only if I put this on the inside, which might actually be the right way. You can see here it has some small channels also, so let's try it. Okay, that worked really good. So I'm putting this back together in the right way. Okay, I put a little bit more tape on the second live wire because in this position I've got good access to it. And if I can make this a little bit safer, I will gladly make it. So, putting it back together. Okay, no LED. So if it's in the right position, you don't see the LED. That means it was never in the right position. It will not. Okay, we had some visitors. My wife just come in, and because I was recording, she went away. So now we see the LED. We are putting this back together. Of course it doesn't really like to be back together, but what can I do? Let me find a little screw. Okay, all is well. So if everything is right, this should not blow up. I'll go search for an adapter or something so you can see it working. I found the adapter. I've plugged it in, checked the voltage, all seems okay, and now we'll do a test to see if my phone charges with it. Not yet. Okay, it started to charge. I'm not sure if you can see it, but it has a green LED right here when it's charging. If you shut it down, the LED shuts down. So this adapter is officially working. Job well done, or at least done. My friend will be happy with it, I think, and I will give him the link to the video so he can see what was the problem, how I fixed it, and how dangerous this Chinese stuff sometimes is. But I think I made it a little safer with the electrical tape. So, thank you for watching. Bye.